Hey everyone, welcome to today's Explainer. When ChatGPT first launched, it hit 100 million users in just 2 months. Think about that for a second. That makes it literally one of the fastest growing consumer apps in human history. The sheer scale of adoption is just mind boggling. But if you're the kind of person who loves to really get under the hood and figure out how things actually tick, you're probably asking yourself, what is actually happening back there? Well, today we're demystifying exactly that. We're going to completely unpack the invisible engine that's powering this massive, unstoppable wave of generative AI. My goal is to break down how this tech operates, way past the surface level. And honestly, the best part? You absolutely do not need a PhD to grasp the elegant logic driving the whole shebang. Let's dive right in. Right? So whether you're brainstorming ideas with ChatGPT or maybe you're prompting Midjourney for some stunning digital masterpiece, or even just glancing at one of those AI summaries at the top of your Google search, there is one very specific hidden invention running the show behind the scenes. It's so easy to just look at that polished output and marvel at it like it's pure magic, but the actual mechanism making that magic happen, the real nuts and bolts of the computation, that is what we're going to figure out today. So what is the common denominator across all of these incredibly different platforms? Seriously, what connects a text chatbot to an image generator to a massive search engine? The answer is one single, totally revolutionary piece of architecture known simply as the transformer. Okay, but what is a transformer exactly? I mean, it's not a giant robot in disguise, as much as we might all secretly want it to be. Basically, it's a very specific, highly innovative type of neural network. And when this architecture was first introduced, it was a real game changer. It completely disrupted decades of AI research practically overnight. All the old paradigms, tossed right out the window. And the craziest part is that it wasn't even that long ago, which just makes its current total dominance of the tech landscape even more wild. Back in 2017, a team of researchers at Google dropped a paper that would literally alter the trajectory of tech forever. And they introduced it with what has to be one of the most legendary mic drop titles in academic history. The paper was literally just called "Attention is All You Need." That single word, attention, is absolutely crucial. It's the key to everything we're covering today. It's basically the dividing line between modern AI and, well, everything that came before it. To put it in perspective, before 2017, older AI models like recurrent neural networks or RNNs read text a lot like a slow, sequential turtle. They had to process information strictly word by word. And as you can probably guess, that was incredibly slow. But honestly, worse than being slow, they kind of had the memory of a goldfish. By the time an older AI got to the end of a really long paragraph, it had essentially forgotten what the very first sentence was even about. It just lost the context entirely. Transformers changed all of that. Instead of going one word at a time, transformers process everything simultaneously. Because they use parallel processing, they are blazing fast, and they can hold on to massive, sweeping amounts of context all at once. And that brings us directly to the core idea, the absolute secret sauce of this whole architecture. It's a concept called self-attention. Now, to be clear, this isn't human focus. It is a highly sophisticated mathematical weighting system. When a transformer reads a sentence, it doesn't just scan the words and treat every single one equally in some vacuum. Instead, it actively asks this computational question: which other words in this entire input actually matter to understanding this specific word? Let's look at an example. Take a simple sentence like this: the trophy didn't fit in the suitcase because it was too big. Now, for us humans, our brains parse this instantly, right? We read it and intuitively grasp the physical meaning without breaking a sweat. But for a computer, a sentence like this is actually a massive, complex puzzle that relies entirely on context. Because this entire puzzle centers around one tiny, ambiguous word. What exactly does the word "it" refer to here? Is it referring to the trophy, or is the suitcase the thing that's too big? Take a second and just realize how your own brain just naturally solved that grammatical puzzle, completely based on the subtle context of the words "too big" and "didn't fit." So, the million-dollar question is, how does an AI solve this without having our human intuition? The answer is self-attention. Self-attention mathematically scores every single word against every other word all at the same time. It assigns them numeric weights, so by comparing the word it to trophy, to suitcase, and to big, the math heavily favors trophy based on that surrounding context. And here is the truly mind-blowing part. The transformer doesn't just do this for one sentence. It does this massive, complex relational mapping for thousands of words all at once, in parallel. That unique mathematical trick is exactly why this architecture is both incredibly fast and hyper-aware of context. Okay, so once the model has used self-attention to perfectly map out and understand all the complex relationships in your prompt, it has to actually talk back. It has to pivot from understanding to generating. And it does this by predicting exactly what comes next, just one token at a time. And remember, for an AI, a token isn't necessarily a full word. It's often just a chunk of data, like a single syllable or a few characters, which actually makes the whole process way more efficient. Here is how that actual generation loop works in practice. It's called autoregressive generation. Sounds fancy, but here are the steps. Step 1, you feed it a prompt. Step 2, the model mathematically predicts the absolute most likely next token based on all its training. Step 3, it takes that brand new token, tacks it onto the end of your original prompt, and then feeds that whole new string right back into itself. And step 4, it starts the entire process over again to predict the next token. That rapid, repeating loop is literally how ChatGPT writes a highly nuanced 5-paragraph essay. It is just making one mathematically brilliant guess at a time, guided by billions of parameters. Let's zoom out for a second and look at why this matters on a much grander scale. We've talked a lot about text today, but because transformers use parallel processing, they can be scaled up to train on just unimaginably massive data sets. And that scalability, that is exactly what unlocks a paradigm shift that goes way, way beyond just clever chatbots. See, because this architecture isn't strictly tied to language, it can process practically anything that is sequential. We're talking pixels in an image, notes in a grand symphony, lines of Python code, or literally even genetic sequences. AI to date can translate languages perfectly and generate crazy detailed images because it's using the exact same core self-attention mechanism. It just applies that mathematical weighting to different types of data. It figures out how a pixel relates to the pixels around it, exactly the same way it figures out how a word relates to the words around it. So as we wrap up our explainer today, I really want you to keep this foundational concept in mind. The very next time you open up a generative AI tool, type in a prompt, and watch it instantly create something brilliant out of thin air, you'll know exactly what's going on under the hood. You'll know that you're witnessing the direct legacy of that 2017 Google paper playing out right in front of you. Which leaves us with a pretty fun final thought to ponder. When you see these incredible, almost human-like outputs, is generative AI really magic? Or when you get right down to the autoregressive loops, the massive data sets, and the parallel processing, is it just math paying attention? It's definitely a fascinating way to view the tools that are reshaping our digital world right now. Thank you so much for joining me for this explainer. Keep asking those great questions, and I can't wait to break down more concepts with you soon.